Thank you for coming today. How is everyone feeling? Like, good? Excited? Yeah? Ooh. Yeah. So for those of you who don't know me, my name is Wang. I'm currently a developer advocate at Google Cloud. Previously, I'm a software engineer in Google, so working in the industry as a software engineer for 6 years. Recently, switched to developer advocate because I'm really passionate about sharing AI knowledge. Yeah, that's why I'm here today. I'm very excited to start this talk. And I'm going to start with this agent. Everyone's here familiar with agent, right? Anyone don't know agent? Don't know. Okay, nobody. Everyone's here know agent. Okay, so I'm gonna go really quick. Really quick, so just quick review. What is agent? Agent, we have the system prompt to define what is a role. We have the session, like a memory, to store the conversation. And we have the model here. And usually you can put Gemini or any model you want. And we have a toolbox. With a toolbox, model gonna decide, okay, which tool I'm gonna use. And then do I need to use a different tool, or am I ready to return the response? Since most of you are already familiar with agent, I'm gonna go quick with this part. And why we want to build agent? It is very flexible, you can reasoning, and you can easy to prototype, and it's proactive. But, nowadays, we're trying to build agent for everything. We're trying to use Gemini for everything. So oftentimes, you need to really think about, does it work to build an agent for it? Sometimes you can just simply using a model, to solve it. You don't have to using an agent. Right? Sometimes you can just simply have a traditional logic to do it. You don't have to use agent because it's expensive to use model. So even though today's talk is about agent, but I want to mention that you don't have to always use agent or use Gemini because this is an option. All right. So I want to introduce the ADK, Agent Development Kit. So today we're gonna build Agent Development Kit with vibe coding. Isn't that excited? No? No excited? I'm gonna share what is Agent Development Kit, and I'm gonna do a live demo on how you can actually build an agent with Agent Development Kit. Any of you who are familiar with Agent Development Kit? Okay, we have a few. Great. And also, I'm gonna talk about how to use ADK to build MCP server as well, since this is something you may be interested. But okay, before we continue, I'm gonna talk about why we wanna use ADK, because some of you don't know what is Agent Development Kit. Why we wanna use Agent Development Kit? We have so many agent framework now. We have Crew AI, we have Pedantic AI. Why you wanna use Agent Development Kit? Because it's very easy to use and it's modular, flexible. I'm gonna show you really soon. And they have a web UI, or like a ADK UI that you can just instantly test it. You can see the result. You can evaluate the agent, which I'm also gonna talk about today. And it's also native multimodal support that you can have the audio input, and it's deployment ready. You can deploy to Cloud Run or Agent Engine, or because it's very easy in Google Agent Stack. So today's agenda is I'm going to start with the tooling. I'm going to talk a little bit about how do you build MCP server with ADK. And then I'm going to start with Gemini CLI and do some demo on how do you add MCP to Gemini CLI. And next is we're going to talk about context engineering. How do you add memory to Gemini CLI so that you can build an ADK, build an MCP with Agent Development Kit? And I'm going to wrap up at the very end. So this is today's journey. I invite you to join me. And I'm going to start with this tooling part. We have this agent, this toolbox with tooling that you can use a tool to call API or fetch from database. But how does the tool work? Maybe you're already familiar with, or if you're not, but I'm gonna just quickly talk about it in case you don't know. Am I going too fast, or this is okay? Perfect. Okay. Thank you. So user will send a prompt to the agent, and then model gonna select a tool. So oftentimes people would think, okay, so model gonna make a tool call. But in reality, it is not. It is model make a decision And then the agent framework gonna selecting the tool. So what's next is agent framework gonna call the tool, because so the first step is you're selecting the model. It can be the Gemini Flash or Gemini 2.5 Pro, and then it is selecting the tool, and then the agent framework calling the tool. And once you have the output, you generate the agent's response to the user. It's not like model send the response to the user. So I just want to correct that, because often, like I heard like some people are mentioning that, oh, it's actually the model calling the tool. It's actually not. And so getting to more detail, for example, I want to tell tell agent, hey, can you find a ramen next to me? Because I feel like ramen today. I'm not sure how you feel. Yeah. And so I'm going to do a reasoning, say, okay, I'm going to think about it. I'm going to pick a tool. And then it's the agent framework gonna selecting and make a function call. In this case, you're gonna say, okay, I'm gonna using Google Search as a tool. By the way, Google Search is a built-in tool in ADK. So if you're using Agent Development Kit, you have Google Search tool defaultly. Also, it's built in Gemini CLI. Just want to mention that. And okay, so I'm gonna use Google Search. Say, okay, I want to find the best ramen near Sunnyvale. Okay, near San Francisco, because I live in Sunnyvale, so that's why I use this example. And so the frameworks execute with the API call, and finally agent process the result. So we get the final response. So this is like usually how agent use their tool under the hood. All right, so next is, because we're talking about the tool, we cannot just ignore MCP, right? Because now we're talking about the MCP. So what is MCP? Like, how we're using MCP? How many people here are familiar with MCP? All of you, most of you. Like, we have few of people here who not familiar with the topic, but most of you are. Have you built MCP server before? We have a few. So most of you are familiar with the concept. You probably use MCP tool in your agent. Okay, cool, wow, very experienced. And yeah, so how does the MCP work? Basically, when we talk about MCP, we usually have a client side and the server side. So we don't just directly, you don't directly fetching things from MCP server. It's like MCP inside the MCP server, it connect to different tool. And usually the client side is an agent. And then it's connecting to the server side. So when we connect to the server side, it will list all the available tool. So MCP is actually the universal adapter. So it's like I have an adapter, I have a different tool, and I can connect to those tools so that the client side can use those tools through this universal adapter. So when I connect to it, I list all the available tool, and then I will call the tool I need. So in today's session, I'm gonna talk about how we're gonna build ADK, use ADK to build MCP server. So usually ADK, like we talked about ADK framework before, right? We have the agent, we have the brain, like model as a brain, and I'm gonna choose a tool from the toolbox, right? So that is the agent set, right? So MCP server is actually like inside the toolbox. And for ADK framework, we have 3 types of MCP server we can build. You can have your connect to the API you want. You also can build your customer function. You also can connect to the database. So here, so this is like with the ADK. This is the ADK agent as MCP client. So this is a model. So inside the tool here, we have the MCP server and it's connecting to a tool. So here, we are using, we're connecting to this DB so that this agent can do a DB fetching in this case. But we are able to build we are able to build MCP server that connect to the API call and also have the customer function as well. But for Google Cloud, it has a default database one, MCP toolbox that connecting to all the different tools. I also want to mention that you with ADK agent, you can use this MCP toolbox, or you can write your own tool to build RAG in the tool. Anyone of you know RAG? So RAG, most of you are familiar with. So RAG is like retrieval augmented generation. So you have a vector database, and then you put you have the embedding with the item in the vector database, and you have the whenever you're trying to search or query something, you're trying to do the similarity search in this vector database. So that's basically the RAG flow. So for example, if I wanna I want to search for like what is the nearest ramen. So in my database, it may have the ramen, may have the sushi, may have like other restaurant like Thai or American, and then the query. So I get embedding for my query. So what is a ramen? And then I'm gonna do a similarity search in this database. So that's a RAG. So with agent, you're able to creating a transactional, creating the vector DB in Cloud SQL in the transactional DB, and then you can building the whole RAG in the tooling. So if you're interested, I'm going to show the demo or show the tutorial at the very end. But I just want to quickly mention that those are how powerful ADK is, and you can use them for. You can use them to build different type of MCP server, and you can even implement RAG with agent. All right. So now, let's go to the Gemini CLI part. Am I going too fast, or everyone's, okay, do I lose all of you? No? Yes, a little bit? So if you find I'm going too fast or it's a lot, I have all the content I have at the very end. I have a QR code for them, so you can always read them later. Because I always have only have limited time, I cannot go to the detail. I'm sorry. And then, okay, so next part is Gemini CLI. Gemini CLI is a tool that you can just wipe coding in your terminal, and it is a power. So you can build everything in your terminal. A terminal is open source, it's AI tool to automate the task, and you can wipe coding it. You also have the Google search and MCP server. So Gemini CLI is actually also an agent. So Gemini CLI, you have an agent, it has a model. You can choose different model to vibe coding. And Gemini CLI also have the tools. So Gemini CLI tools, you have the user level tools and project level tools. So user level tools is like global. If you define a tool globally in the user level, it can be applied to any project. So if you define the tool in the project level, it can only be accessed in the tool in the project you define. We also can define the memory, the context for Gemini CLI. So for the context for Gemini CLI, we also have the user level and project level. So if you save any knowledge, so for example, I want to tell Gemini CLI, my name is Annie. I can save this to user level. So all the project would have this memory of, okay, my name is Annie. Because if you just talk to Gemini CLI, and then if you say, hi, my name is Annie, and then you close the conversation, they don't remember my name anymore. So if you store this to as a context, then Gemini CLI can later on use this to build, to do web coding. So you can leverage the tool, the context, to help you build agent or MCP server, which I'm going to demo really soon. So here, you can first pick the demo or pick a model, and then you can, so for the project root project root directory, the project level, you have a file called Gemini.md. So that is the context for project level memory. And we have the set installed a JSON file in the project root directory. That is the project level tooling. Similarly, we have the Gemini MD file and set installed JSON file in the user level, in the root level. So that is a global level tooling and memory. So you can directly modify those files to help you better web coding. And you can also you can configure your MCP by adding different tools in Gemini CLI, just directly put MCP server there, so that you can superpower your Gemini CLI. You can also have a sandbox, because oftentimes you find AI just completely ruin your project, and you cannot revert it back. So you can open the sandbox testing things, and once you quit sandbox, it just automatically revert to the previous version. So it's a playground for you to give a try. So all right, it's enough about talking. I can just show you about what if I have the model and have the MCP server. What if I have the Imagen as the MCP server? I connect it to Gemini CLI. How do I do that? And I can give a live demo of how do I generate a picture using Imagen as MCP server in Gemini CLI. I can show you the tooling, the memory file in Gemini CLI, and then give you a live demo of how do I generate an image. How's that sound? Cool. So here, let me first making sure I'm in the right environment. By the way, I have all those so all the demo here today, everything I'm talking about, also I have them in the QR code at the very end. So even this whole project, you can try it. If you're interested, you can try it at the very end. So first, so right now, I'm gonna open this Gemini CLI. This is how you can open it. You just simply type Gemini. If you already install it, this is the model I'm choosing. I can choose Flash because it's fast, and YOLO mode is always choosing. So every time, if Gemini CLI make a decision, it will ask you. So YOLO mode, it will always help you make a decision. Like it will also grant the permission so that you don't have to always answer. For Gemini CLI, okay. Have to auth. Okay. Let me try. I hope it works with live demo. Okay. Interesting. Cannot log in. Okay, let me refresh. Sorry about it. If it doesn't work, then I can just give you a demo of what another account that I already have. Okay, the Wi-Fi is good, and I think I'm at the right environment. Okay, I'm gonna give another try. If not, I can reinstall the Gemini CLI or, okay, let's see. Okay, ask me to, interesting. Okay, let me authorize it. Okay, great, it works. Yay. Thanks for your patience. This is how it looks like. Like you have this whole Gemini in this, and I can just simply type /MCP. So this is, I already successfully connect to Imagen. And yeah, so this is, so if you wonder how I connect to Imagen, basically I adding the, so what I did is, I'm gonna show you on the code here that, so what I did is I simply put this Imagen here in the Gemini settings JSON file. This is so this is a local server, but like the point is you have the server URL and just simply put it to the settings.json. This is where you're adding all your tools. So now if I put in this here, I'm able to adding this. I'm able to use Imagen as a tool. So now I'm gonna ask Gemini to Gemini CLI to generate an image for me. So what image you wanna generate? Anyone have an idea? Ramen? Okay, sure. So generate ramen for me. Generate a picture of ramen. Okay. Generate a picture. Sorry, I'm typing with one hand, a picture. So it's a little bit slow. Generate a picture of ramen for me. Let's see. Okay, it's using Imagen MCP server, prompt ramen. Let's see what a picture is created. So I'm generating ramen for you. All right, you can find it at this link. I'm curious to see how does that look like. Let's see. Oh, wow, looks pretty tasty. Cool. Yay. So now we successfully generated this image in. I can also show you that for the memory. Now if you simply type a memory.show, you can see this is all the memory I already fit in here. So here I have this user, this is the user level, and this is the project level. So what you do is simply putting everything in the Gemini.md file that later on I can show you in the code. All right, so thanks for seeing this image and demo. I'm gonna continue with the vibe coding challenge. So I assume most of you have tried vibe coding, right? No, you should try it, okay? Try Gemini CLI today after you feel interesting. You can generate image just in the terminal. You're not convinced? Okay. Sure, you have your choice. Okay, so vibe coding, nowadays the vibe coding challenge, it's hard to understand what you build because oftentimes if your code base is very big, it's kind of hard to understand exactly what you build and get integration right. Also think ahead for the production challenge. So oftentimes you just it happens that you tell Gemini, here's my script, can you do this to me? And then Gemini was like, okay, let me do this. I'm gonna do this, and then you're like, oh no, why did you completely change my code? I mean, this happened to me. I'm not sure it happened to you as well, but like oftentimes you may note, like I did notice that Gemini, not Gemini, but in general vibe coding, the AI trying to generate, like if you just simply tell them one thing, like generate a website for me, or like a very vague prompt, it sometimes just have some unwanted correction. You will change some, fix the unwanted problem that intentionally do that for the design, or you broke the contract. So it can be very challenging to write a good prompt. It can be very challenging to use either Gemini or any other model you like. If you like, cloud model, if you like ChatGPT model, if you like other open model. So the core is the discipline of context engineering. So today, I'm showing you how to do this memory, how to so I'm just give you this example of how to do context engineering in Gemini CLI, but the core is, how do you adding how do you do the core is the discipline of context engineering, how to add the memory so that you can use this, get inspired from this to use any, if you're interested in other model, you can try a different model at home, right? All right, so the discipline is first you want to optimize your prompt, and then for the short-term memory is my conversation, like one single turn with the model, like I'm talking to the model, like one thread. So that is short-term memory. You need to be smart about that. Also the long-term memory, you can put code style guide or architecture principle, or you can also put like some document, some technical document for the long-term memory for the project, and also you can put this some policy or guardians in the user level, like long-term memory. So I'm gonna show you how. I'm gonna give you a live demo of how I using Gemini CLI to build an ADK and to build an MCP. I'm not sure if you still remember ADK, MCP. I talked like 10 minutes ago. So now I'm gonna try building this, follow those principles, adding the short-term memory, have a good prompt, adding a long-term memory, and I'm gonna show you how do I build this. Okay, so of course I'm gonna use this project level and user level memory. So not only using the Gemini.md. So I did show you the memory, the Gemini.md file previously, right? If you remember, I can also adding other files in project level or user level, and then tell Gemini to read those files. So the file that I intentionally added and asked Gemini to read can also serve as a memory context for me, and you can put design or guidance there. And this is how I'm going to show you over here. Okay, I'm going to open so here I have this file called agent design. So in the agent design, I basically put down all the key detail of the how I want to build this agent development kit. So you have to using. So I'm telling you have to using Google ADK. You have to using this type of ADK because ADK has different agent type. And this is how exactly you have to connect to the MCP server, and what is the model you're trying to use, and stuff like that. This is a project level memory, so this is called Gemini.md file. And in the Gemini.md file, I just telling AI, this is a coding guidance. You have to follow the best practice, Python best practice, and at least what are the best practices you have to follow. And then what I do next is, I'm telling, so this is the prompt I'm gonna using. So I'm telling Gemini that you can analyze this design doc at this file. So if you do add a file name, Gemini CLI can access that file. So you can put all the design guidance in that file, and then Gemini CLI can use that. So basically, you have the system prompt that define the role for the agent, and then ask agent to access different file, and then this is what you want them to do. So now I'm gonna open the Gemini CLI, I'm gonna run this command, and I'm gonna see what is the file is generated for me. Okay, wow, it's quite long. So I'm gonna quit this first. I'm gonna clean this. I'm gonna get ready for this file. Again, like if you want to try this yourself, I have this link with me. And I also have free credit for you so that you can use a free Google credit to try this yourself. Yay. Am I over time or? Good? Okay. Cool. Okay, so I'm typing this. So this is what I told Gemini that, oh, you're the expert at Python developer, and this is the design file, and this is what you want to do. And then let's see. Okay, seems like you successfully created agent.python. Okay, so see, it's successfully creating this ADK for me. And it's connecting to MCP server as well. It's using the 2.5 Flash model. It has an instruction. And this is how it's integrating with MCP tool. So this is the example of how I creating the client side, the MCP client side. So now let's see the MCP server side. Remember I mentioned that you can build MCP server with ADK. I'm gonna show you what does it look like. What does it look like to use ADK, build MCP server? So again, I copy this command to build. Oh, sorry. Okay. Good. So I'm asking. So this is a command I'm telling agent to do. So I'm telling agent that, oh, you need to build MCP server. I'm telling Gemini CLI that you need to build MCP server, and this is the things instruction you need to follow. And let's see what it's already creating the MCP server for me. Let's see. So you can see that in this MCP, this is how you can use ADK agent framework to build MCP server. First, you define the tool by, here you define all the available tool, simply with this declaration. And also you need to define the list all the tool and call the tool, which I probably don't have time to demo here. But yeah, so and just it's an example that how you can creating MCP server with Gemini CLI by using this context engineering mindset. Basically, what I did to summarize, what I did is I adding the guidance in the Gemini.md file and also adding the instruction in other file, and then I'm guiding Gemini CLI step by step to creating ADK for me. Cool. All right. So finally, next part is evaluation. Now I build an agent, right? But how is agent good? How do I know if agent doing what I want? So that's why I need to evaluate. If the agent is not if it's not good, how do I I cannot just push it to deploy to production, right? So I need to evaluate it. And in ADK, you can create an integration test, and there are 2 building metrics. You can define the expected trajectory and expected response. What does that mean? So that means that you need to check whether the model, whether the agent is choosing the right tool and whether they're choosing the right tool at the right time. So that is a tool trajectory. Also, we have the expected response. Basically, we are trying to evaluate how does the response compare to what we expected. So you can run the agent with queries through ADK, agent, usually through the ADK web, and once you run it, you get the actual trajectory and actual response, and then you compare the actual and the expected, so that you will get an evaluation report if you run the ADK web. You can also run it by directly testing run it programmatically, and you can have this score to check. Tool trajectory score and response matching score. Basically, if you put the tool trajectory score to 0, do you know what will happen? Guess. Can I have someone? Okay, you're listening all the time. Okay. Okay, so if I put it to 0, it will always pass because it's defined how strict it is. So if I put it to 1, it has to do exactly what I want. If I put to 0, it can do whatever. It always pass the test. So basically, the score here is I will define how strict it is, because oftentimes AI is non-deterministic. You cannot expect it always doing 100% what you want, right? So here you can define the score and to see how strict it is. And all right. Eventually, you can also build the whole CI/CD pipeline with Gemini CLI, which I'm not gonna explain in today's session, but I do want to mention that you're able to, using the Gemini CLI, to build end-to-end agent workflow, everything from the prototype to evaluation and building deploying to building a Docker. You can write a Docker file and you can deploy, yay, Docker. And you can also build a CI/CD and everything end to end. So I have that everything in this collab. If you want to try, so this is the collab I built that how end to end, how do you connect, how to use Gemini CLI and Cloud Assist to adding this imaging to the ADK, and this is how do you build everything from the idea to production-ready agent. So if you want to build making your idea into reality and put it to production and automate the whole process, this is a process you can try. And this is a lab I just run with you today. And this is a free credit if you want to give a try. So you can use this free credit, redeem the credit, and then you can try the lab. So this is the demo I have for today. It's also the end-to-end, but it's adding more instruction, giving you more explanation on the Gemini CLI part. All right, so, okay. All right, so yeah, this is my social. If you want to stay connected or ask any question, you can. I'm happy to connect with you on the social. And yeah, thank you, everyone. Thank you so much. I hope you enjoy the session. Thank you.
We can spend 5 minutes for Q&A if you have any questions.
Yes. All right, I'll give you mic.
Yeah, you use the MCP server and the tool, right? Maybe we skip the detail part.
Yeah, I skipped it. Do you want to see the detail, or is that?
No.
I can show you the detail.
I have some questions.
Okay.
So, before the MCP protocol or MCP server, what exactly we use for the agentic AI process? Because there are multiple protocols like MCP or Google's AI2A, and there are other protocols also be there. So why we are choosing the MCP server? And suppose if the MCP server protocol is not available, before that, what exactly we use the implementing of the agentic AI process? I just ask because I'm a very entry level, my knowledge, I want to understand it and why we are using the each protocols, MCP or A2A or else SCM, or there are multiple bunch of protocols.
Yeah, so the question is why we're using MCP. What if you're not using MCP, how do we connect the
prior
tool?
to the MCP, what exactly we are using?
Yeah, so you can directly define a tool. You can create your own tool. You can create a custom function in the tool by defining a logic. For example, I want to build a tool like do the multiply, like a mathematic calculation. You can write your own function, or you can connect to API call. But for the tool you're building is only for your agent. It cannot be used for other agent unless like you build a different tool for different agent. But if you have the MCP tool in the MCP server, like this can be used for all the agents that connecting to this. So it basically make it easy. But before MCP server, you can just directly build in your tool by making a customized tool. I hope that answer your question. Yeah.
All right. Another question.
Okay.
I have a few questions.
Have a note.
Can I use different models other than Gemini? With,
Sorry?
Can I use different models other than Google's model?
Of course, yes.
And then is this can be integrated with other editors like Vim or something?
Yes, of course. I just use this to demo, but yes, you can use it.
And is there a provision to profile the LLM prompts given by the, check the prompts, what prompts are given to the LLM by the CLI? Is there a way? Or?
So the question is this Gemini CLI checking the prompt?
No, if I want to see what prompts are being given to the LLM.
Oh, you want to check the previous chatting history?
No, when we type something,
Yeah.
it's eventually sent as a prompt to the LLM, right?
Yeah, so that is the prompt you send it.
Yeah,
to.
so can I see the prompts?
So basically the chatting history is the prompt you send into the model. So if you say, hey, my name is Annie, that is you're talking.
That is the only prompt, so.
That's a chatting history.
So what about this Gemini MD and all? Those.
Oh, Gemini MD file is a memory, so it can store something so that you can, for example, you are having a design doc, or if I want to build an ADK, I can just copy paste the whole ADK doc to the file, or I can put some of the guidance in the memory so that whenever I'm using this Gemini CLI, I can always refer to this memory, to help me build better project. So those are tools to help you build.
So if the agent needs to know about the memory, it has to be given to the LLM, right?
Yeah, but you can make you can make the memory empty. So this is just for you, it's a tool for you to better writing your code. But you don't have to add in memory. This is optional. It's default as empty.
Okay.
Yes.
And so one more question. Is there a size limitation on Gemini.md?
I think I need to look into that. I haven't over the limit yet.
Thank you.
Thank you for the question.
Thank you.
Thank you.
Hi, just a quick question on when to, have multiple agents. So, what principles should we consider if, say, we want to have a design agent or a QA testing agent, and how do we chain them together? I think you helped show how to make a single agent, but I'm just curious how to, when and how to, build multiple agents in a team.
Yeah, I think that's a really great question. And actually, so if you're not building a very simple task, I think from my point of view, I think most of the situation you should use multimodal, a multi-agent frame structure, because with multi-agent, according to research, the cost is relatively lower and it's more accurate. And so how you do the multi-agent is usually, so ADK has, I don't have ADK on the screen. Yeah, ADK has built-in support with workflow agent. So they have the built-in workflow agent that they provide sequential agent that can run the agent in a fixed order. They provide loop agents that they can run the agent in the loop. So you simply just put the things in the loop in the sub-agent of the agent. So you can run things in a loop, and they also have a parallel agent. So you simply put things in the parallel, and you can also put agent as a tool, as a part of the tree. And for the LM agent, you can also have native tree structure, tree hierarchy structure. So you can leverage, so if you build this ADK, you can leverage with ADK's workflow agent and LM agent to build your multi-agent system. But if you're building different framework, or it's really the design, so it's a design choice. If you want to connect with different agent, you can, if it's deployed on the Cloud Run, you connect with A2A. Sorry, I'm talking too much.
Got it.
Yeah.
I guess in my mind, I'm thinking of like N8N, Crew AI, they have some frameworks.
Yeah, you can connect with them with, so ADK has a tool to connecting with LangChain, so you can using those as a tool, but not using agent. And also you can connect with everything with A2A. So A2A, basically you have an agent card that describe what the agent does, and you're connecting through agent-to-agent protocol. Okay. That I can show you later with some tutorial if you're interested. Yeah.
Thank you.
Yeah.
Thank you. We're going to take 2 more questions.
So many questions. Do we have enough time for next one? Okay, sure.
Oh, sure. Okay. Annie, thank you very much. Great presentation.
Thank you for coming. Yeah.
Of course. I wanted to touch upon how ADK can access Google Suite. For example, can ADK access my calendar and determine that I'm free at a certain time, and can spin up another agent to look for events that I want to attend?
Yeah.
Is that possible?
Yeah, like if you have an API and you can put a connect API with through tooling. If it already exists with MCP server, you can use existing MCP server. If it doesn't, you can build your own tool to connect to that API. I have some tutorial if you want.
Okay.
I'm sorry, I don't have everything here, but on today's slide, yeah, I can connect later.
Absolutely. Thank you very much. That was a great presentation.
Thank you for the question. Yeah, for those of you who need
Jamie.
some more results, I can share.
Thank you, I appreciate it.
Thank you.
Thank you for the talk, Annie. Please find her after the session if you have any questions. Next up is Jim from Docker.
Thank you, sir.
This is live too, eh?
Yeah.
Well done, Annie. That was a great talk. I'm kind of going to do the same talk as Annie. So I think it's actually going to go pretty fast because I'm also going to talk about models and MCPs. I'm going to start by my name's Jim Clark. I should have introduced myself. I've been working at Docker for about 2 years, and when I first started working at Docker, I remember when I first saw Docker 10 years ago, and I was like, this is exactly what I want. I just want to like put something in a container, move it, and run it. And when I came and worked at Docker, I was like, aren't you guys done with this product? Like, it's pretty simple, right? Like, Docker pull, Docker run. Like, these are 2 verbs, pull and run, and that's what we do with it. Like, wherever software happens to be, we pull it down, and then we run it. And what did this unleash? This kind of unleashed the cloud, right? Because the cloud is something that can pull and run software for us. And that's why Docker is so central in the cloud. Why it's not a public company and more than 500 people, I have no idea. But hopefully we'll get there. But throughout this talk, let's think about pull and run, because these are like 2 really important verbs. And why are we now looking at AI? And in some ways, I think AI is also a little bit about the kinds of things that you can pull and run. And AI has, like, when we build Gen AI applications, we've actually introduced a couple new types of sort of like weird entities. Like, I don't know what a model is. It's a weird digital object that none of us thought existed 5 years ago, and now it's amongst us, and we're trying to deal with the fact that this thing exists. For a long time, it wasn't something you could pull with Docker. And we got a lot of people coming to us and saying, why can't we pull models? Why can't we pull the weights of models? And we're like, yeah, I guess we can put model weights inside an OCI artifact. That's like, why not? And so what you see here on the side is like, well, we'll just put model weights into Docker images as well, and you can like pull them and you can run them. So if I jump over to my terminal here, I'm going to probably do a fair amount of terminal jumping. But if I just say Docker model list, I can see all the models that I've pulled down. And if I were to say Docker model pull AI Gemma 3, I've already pulled it. So it's using the one that I've cached. But if you were to go to your terminal and type this command, you would spend the next 2 minutes pulling down all the weights of Gemma 3. And similarly, if I say run and I say hello, what am I doing? I'm loading the weights into a GPU, and it's answered me. What GPU did I just load the weights into? This one. Like this is on my laptop. So I'm pulling to my laptop and running some stuff here. Cool. So that's one thing you can pull. You can pull models and you can run models. Another thing that you can pull is MCPs. So thank you, Annie, for like getting us all ready for this. But like, what are MCPs? Well, I remember like about a year ago now. I was working I do work in this thing called Docker Labs, and we're starting to work with AI, and we're building all these loops, and we're trying to figure out how to get the agents to do something interesting. And I'm not going to show you as interesting things as Annie showed you here, but still, like we wanted them to do something interesting, so they need to call something. And so we were like, it kind of looks a little bit like a Docker container, honestly, a tool. So we started up a project and we called it some horrible name, AI tools for devs. And the idea was, an agent is going to need a bunch of an agent can extend what it can do in the world by pulling a Docker container and running it. And then Anthropic released MCP, and they also came up with a terrible name, Model Context Protocol, whatever that is supposed to mean. So, sorry if anyone's from Anthropic is here. But on day one, we were like, oh, I think that's what we're doing. I think we're building MCPs, and so we started working with them. We've been working with them ever since, because really a lot of what you do need to get working in order to run an MCP is you got to like pull some NPM thing or some Python thing or some NuGet thing or some chocolatey thing, or like there's so many words, I don't know any of them, but you got to pull these down safely and give them to your agents so that they can run them. So this is another case of pull and run. So we have this project, Docker MCP Gateway Run, and it's just Docker, really, with a very, very thin layer around it. And so what do MCP clients do? Well, they need to connect to MCP things. MCP servers, let's just call them Docker containers, or maybe a remote proxy to another Docker container that's somewhere else. But these are all entities that we pull. And then we're looking at what sort of things do you want to put between your clients and all of these containers that run that are going to make you feel safer, that are going to defend against some of these like new style of security attacks. So this interceptor framework comes in place as well. Now, open source, a month ago, we took the MCP gateway and we open sourced it. As many of you probably know, Docker itself is also an open source project. So the idea that you can just take a Docker engine, put an MCP gateway on top of it, and have sort of this primordial ooze with which to like create MCPs, that's the idea of this. This is an open source project. I'll show you the repo afterwards. It's been open source for about a month now. I think in my talk I said let's talk about Compose. So let's talk about Compose. So okay, if we can pull models and if we can pull MCPs, then we can probably just compose up entire agents. So here I'm saying I'm going to build something. I use the Qwen3, however you pronounce that, and I need an MCP gateway. I need Brave web search. Maybe I need the Wikipedia tool. I got to pull all this stuff in. This is and when I say Docker compose up, I don't want to go and install Node. I don't want to go install Python. I don't want to install anything. I just want all this stuff to pull down and run. So we're not trying to be the framework. So there you go, agent development kit. LangGraph, Babel, Crew AI, Vercel, Spring AI. I don't know, like, how are you going to build your agent? These are all great. I mean, agent development kit is the best, but these are all great, right? And so how are we going to choose which one to use? Well, we're not going to try to push you into any choice here. Our job is really just to containerize this up and make it possible for you to use these different frameworks, to use models, and to use MCPs as easily as possible. So let me show you a demo. Oh, by the way, this demo here is, I'm going to show it out of this repo here. So, no, not this one. This is the open source project that we just built. This is Compose for Agents, Docker Compose for Agents, public repo. We just have a bunch of agents that where the hallmark of each of these is you clone the repo and you say Docker Compose up, and a boom, and something comes up. And most of them we've tried to stick with local models so that you don't have to put your Anthropic key or your OpenAI key or whatever. It's kind of just something that hopefully you can use on your laptop. That's the idea behind these repos. And that's what I'm going to show you here. So I'm just going to take a compose YAML file. And you're going to see, you should notice a couple things here. One, I cannot type. Llama 3.2. This is a local model. I'm going to use this here. I'm going to use this Qwen3 model, and I've defined an MCP gateway. This container has that open source project that I just told you about, and we're going to connect to it over, well, whatever, who cares? It has some secrets. I want to bring in two different MCP servers here. I want Brave and I want Wikipedia MCP. So as a developer here, I'm not letting the agent figure out what tools it should have. I'm telling the agent, these are the tools that you can use. All right, so this is not like, hey, go at it. This is like, I want to do something, I want to use Brave, I want to use Wikipedia MCP, and I want to restrict it to just these tools. So I'm trying to like constrain what it is that this agent is allowed to do. So then I just type Docker compose nup. Nope. I control Docker compose up. And this should start up fairly fast because I've cached everything already. But if you can do this, if you run Docker compose up, this is going to take like 3 minutes or something like that, because you got 4 or 5 gigs of Qwen3 weights to pull down and some tiny MCPs and blah, 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 blah. Okay, so I have a localhost 3000. This is the app that started up in Docker Compose up, like in Docker Compose. And so I don't know. This isn't really the part of it. You can put any app you want in. This is just like some random thing that I put in that I think is kind of cool. And I can choose between these two different models, Llama 3.2 and Qwen3. And I've got my MCP server gateway up here. So I've got, what do I have access to? I've got access to Brave, and I've got access to Wikipedia. So if I go in here and I say, do a search for Wikipedia articles on Docker and MCP and summarize. So this is going off to the Qwen3 model. If I bring up my GPU thingy here, my GPU should start to heat up here. Qwen3 is thinking about the problem. It hasn't decided to call a tool yet. It's just kind of like trying to figure out, oh, there it now it called a tool. That get summary there was it deciding that it should call a tool. And when it did call that tool, it just ran a Docker container. Right? So it was Docker pull, Docker run. That's it. So it just said, I need to call it a summary of Wikipedia. Look at my GPU is like heating up the room here, and it's going through and you know, making all the calls that it wants just with these Docker containers. Cool. So let me stop that and jump back over to. Actually, I'm just going to go over and just kill this Docker Compose up, make that thing go away. Now, the next thing I want to show you, oops, I'm not sharing. Slideshow. So that was Docker Compose up locally. Now, what's kind of interesting about Compose files is maybe you can also use them to just move these agents around. And so we've got partnerships with Google Cloud and with Azure. Fly.io as well is a new one. And we really should be able to just Docker Compose up with tools like gcloud run compose up. This is the name I was trying to remember for you, Annie. This is the thing that we're just releasing. So this compose YAML file, why not just run it in the cloud? Like, I mean, it's fun to develop here, but we should be able to just move this around. That's the whole idea of being able to make these things like super transparent. So if I go back now, we also have a little tool here, and if anyone used Docker Desktop, but you probably might want to see start Docker offload. But if you click this button, we'll take your entire Docker environment and we'll connect it to a cloud node with GPUs. And this is another one of those things where, you know, feel free to look it up. Everyone gets like, I think 50 hours of free cloud usage here. And if I go back now and I just type the same thing, Docker Compose up. Okay, this is going to take too long. I was hoping I'd cache this earlier, but it was going to be boring anyway, so you're not missing anything. But I'm running the same thing in the cloud. And if I ran that same demo, it would have gone slightly faster because I had a much better GPU than I have on this Mac OS. But again, just imagine that this whole thing comes up again. It's in the cloud. I do some stuff. Now Qwen 3 is running on a nice NVIDIA GPU in the cloud, not some whatever I have here, right? So that is what we call Docker offload. And the reason I bring it up in such an open source kind of like public context like this is like you really can try this and you can get like 50 free hours of GPU usage. And so when you try out some of these models, go sign up for it, just get some free fast GPUs. Okay, so the next thing I want to go over is. Annie earlier talked about building up your prompt, doing prompt engineering, context engineering, and what we showed earlier in this demo was giving the model 7 tools from Brave and Wikipedia, not an overwhelming amount of tools, and we carefully curated them. And said, okay, here are the tools that I want you to use to solve this problem. Web search, Wikipedia summary, 7 other things. Do something with them. Now, very quickly, what we see when we're building agents is like our actual context window fills up with tools, right? Like you can't give your agent like the GitHub MCP and 5 other MCPs. Suddenly you have like 300 tools in your context. And so this is a real problem of today as we're building things. We're like filling our context window up with tools, and then there's a little prompt, So it's like going to a restaurant and they have like 50 specials, like 4 or 5 in. You're like I can't listen to 50 specials. Like I need you to help me get this tool context into some sort of shape so that my agent is going to do something interesting with it. Then I can start to give it way more tools. So I kind of think about this as like 3 stages. So in stage 1, I'm very explicit with the agent. Here's the 4 tools I want you to use. In stage two, I'm just going to be kind of like, I don't know what you should use. You go find tools that you think will help you solve that problem. Use those. So what do you need then? You need like good catalogs filled with tools that you might want to use. And third, I don't know, make your own tool. If you don't find one, just build a tool, and then use it. Like not just build a tool, but build a tool and then load it into your session and use the tool. Then if you get the problem done, awesome. Build your own hammers, build your own saws, you know? So that seems like science fiction. But like once we start to break that down, I mean, and let's break that down a little bit. Okay, so here's what I'm gonna do. I'm gonna set another little example here. So registry. Let me just sign in with my 1Password here. I'm going to start something up here, which is a new tool. I think it's called Run Registry. Okay, this thing that I've just started up here. I'm going to run it on my laptop. This is called the registry. This is called like the official MCP registry. And it just came out yesterday. Anthropic just announced it yesterday. But we've been working on it in the MCP community for 3 or 4 months now. I can even show you the repo. Another open source repo for everyone here to jump in and start contributing to. So this is the big catalog of MCPs. It's probably going to have like 100,000 things in it within the next year. We at Docker also have, if you open up Docker Desktop and take a look at we also have a catalog. Ours is very curated, but each of these things is just a Docker container that has MCP stuff in it. So this is our catalog. It only has 200 in it because we're just kind of like, you know, really building up and building relationships and partners with all the people that we're putting in here. This registry thing that I started up here, this is going to get massive. This is going to be like NPM or Maven or any of those tools. This is going to have millions of things in it in a year. But what are these things? A catalog of MCPs, like a registry of MCPs. These are places for agents to go look, right? So let me now go and open up a terminal, make this a little bigger maybe, and I'm going to run this command, docker MCP gateway run transport SSE. Okay, so I'm going to start this gateway up. I just started that up with nothing. Okay, so there's no tools in this. I just started up like an empty gateway, a primordial engine for pulling and running things, basically just a Docker engine. And there are a couple of like I call them primordial tools because it kind of like summons tools out of the primordial ooze. MCP find, MCP add, MCP remove, MCP official registry import. Okay, cool. So now I'm going to start up a session, and I'm going to connect it to localhost 8811. So so I'm connecting my chat session to this primordial ooze MCP server that I just started up. Okay, so client initialized. So this thing can't do anything. It doesn't know about tools. It doesn't know about MCPs. There's no MCPs loaded. But why would we just go now and start to edit MCP.json files and statically put things in? There's no point. What we can do is we can say, hey, someone just gave me a link to some server that's in the official registry, and I'm like, okay, I import the official registry server at, and then I just put here. So this URL that you see here, HTTP localhost 8080 servers, blah, blah, blah. This is a URL to an MCP server in the official registry. So these are going to be, we're going to start to hand these around now like calling cards. And when I run this, you know, it's basically going to go, oh, let me go see if that exists. And it does, it finds that exists, and over on the left, we see that oh, it's loaded it, and it said, oh, I found that. I found that MCP. And I know that it needs your Garmin email. This turns out to be like a little MCP for looking at what workouts that you did that week on your Garmin watch. And so it needs your email and your password. I've already told it the email and the password because I don't really have the UI done well enough to just enter it in front of you. But now it's saying like, hey, this is now available in your catalog and ready to be added. Okay, well, then add it. And like why, like hopefully this will work. And why will it work? Because it's just running and pulling, right? Like I found the Garmin MCP server, I pulled it down, and now I'm running it. And it's like looking at it, there's, okay, I see a bunch of, oh my God, what are you talking about? Sometimes it just like starts to summarize the world. Now I gave it a new capability. Because before my session didn't have this MCP in it, and now my session does have this MCP in it. And so what activities did I do in the last 2 weeks? And it's probably going to figure out that there's a tool now in the session to do that, and it's going to send some stuff there. And if this is right, it's going to talk about mostly like me running around San Francisco. And yes, it is. And so I was going to tell you, I was going to even show you another thing with Slack, but it's pretty boring at this point. Like every catalog becomes your sort of thing to go out and find things that it can do and dynamically update your session. There's no reason for you to start and stop. Like these sessions are fluid. You can pull things in, put them out. You make, like a context is what you make of it. When you're programming agents, you fill it with the things that you need. And so when we jump back to this presentation again, the last point I want to make about stage 3 here is like agents that make their own MCPs. Well, okay, if MCPs exist, and if you can just like add and remove MCPs from your session, well, we already have tools like Claude Code. Annie just showed us how to build a brand new MCP. Well, why don't we just have another tool that does that? And when it's done, load it and add it and use it. And then you use it and you go, oh, it wasn't very good. Change it, Like this isn't science fiction anymore. This is actually just a small set of primordial tools that you use to start to build up these sessions. What we need is isolation. And so that's where we feel, if I'm going to say anything that's sort of like marketing-ish in this talk, it's about like, sandboxes and putting things in containers and making them easy to pull and run and execute safely. So I already did that demo. I already did everything. I'm done. Thank you.
Yeah, if you have any questions, we can take some.
Thanks for the talk, Jim. With that last demo, you were running the Garmin MCP server on your laptop?
I was, yeah.
Is there any advantage to doing that over just calling Garmin's MCP server on the web?
No. Yeah, good question. I expect that a lot of those local MCPs will gradually become remote. So Garmin hasn't put out an official MCP. Someone just wrote that.
Oh, okay.
And so a lot of these MCP servers that we see written right now, they are just written by us.
Got it.
Right, the people in this room, and they put them in Docker images, and they're like Garmin doesn't know that we're doing this.
Oh, okay.
Right, and but they have APIs, so they don't. It's not like they don't mind. Okay. So like there was 47 GitHub MCP servers before there was a GitHub official MCP server, right? And the local, the one that runs in containers is still actually really heavily used for self-hosting. I was going to say something else, but it slipped out of my mind. But I think that answers your question, right?
Sure. Yeah. Yes. So it just makes sense to use it now until like an official one comes out.
Yeah, and you won't always find that the official one is better. Like the GitHub official MCP server is better for most things, but it's not like very good for like issue queries and indexing and stuff like that. So I think that we're all in the same soup here, and a lot of stuff is going to emerge as being like agents are going to have a better understanding of how to choose tools sometimes than we do. Like we're at a time right now where we're learning that too many tools is not good, right? And a lot of MCP servers they're getting a lot of pushback. They're like, why did you just put 175 tools into my context? Like, give me a break. That can't be, like, an API is not necessarily a tool call is something that we're learning right now. There's a lot to learn.
Thanks.
Yeah.
Hey, thanks for the presentation. I didn't know any of it, so it's stuff that I can dig into a little bit more later. But can you explain a little bit how the gateway works? If I point the MCP inspector at the gateway, what will I see? Yeah, so the gateway is an MCP server, and so we really just we made every MCP behind the gateway broadcast its capabilities to the front, and so the MCP server the gateway acts like an aggregate MCP server for everything that's inside of it. So basically, all the tools are there. Are you also looking at A2A implementation in the gateway? No, not yet. Okay. Last question, I promise. How do you ensure you're building a catalog now, right? It's like we just recently had an issue with one of the supply chain attacks that got Visual Studio Code extension basically hacked, and a lot of people got hurt. How do you ensure that the MCP servers that end up in the catalog are? Yeah. So at Docker we have a I'm actually at Docker because of supply chain security. They acquired a company that I founded, which was 100% about that problem. And so that's actually the reason that I'm kind of into MCP right now, is to make sure that we have a way of safely verifying the supply chain of everything that we're willing to call behind these gateways. So the gateway is open in the sense that you can put anything you want in it. But if you pull things from catalogs where we verify the provenance of the build, we verify that it came from this particular commit, we sign the software bill of materials, we make sure that if there are any vulnerabilities that they get repaired. Like this kind of thing for making your whole MCP ecosystem safe, that's actually where Docker's business is. So everything that I told you here is free, open source, and everything that we're gonna do as a business is around securing. So we've got the best people on it. Thank you.
Hi, thank you so much for the presentation. It was great. So my question is related to the functionality of the, like the definition of the Docker remains the same for all the 3 stages that you have mentioned, or like the functional, is it just the functionality within the Docker, or the definition of the Docker itself changes for 3 stages?
Yeah, no, the definition of Docker remains the same. So when you have something like an agent that builds a tool and puts it in a Docker container, that is, when we say container, we're meaning exactly the same thing as if you found the container in one of our catalogs.
Okay.
So the idea of a container is really just like a runtime that can host your MCP and that you can move around.
Okay. Okay. So those are like functionalities within the Docker.
Yeah.
Okay.
Yeah.
Okay.
And I don't know. I mean, I sort of feel like that's probably not a great answer. So feel free to track me down and make me answer that correctly.
Sure. Thank you so much. Yeah.
Thank you. Let's take this guy. Thank you.
Thanks a lot for showing new commands in Docker. So how exactly to use them? I mean, what version? Do you need to have a special version of Docker?
Yep. So
latest is always the best, but 442 to 445 all have this. Again, you look confused, so I can come over and make sure that that's working for you.
Yeah, I have September 3rd version. It doesn't have it, so
yeah, no, I mean, there might be some little button that you need to click or whatever, but you don't leave without it working, because it's available to everybody here. It's
cool.
Like it's been available for like 3 months now.
Great, thank you.
Yeah.
Thank you, my friend.
First of all, thank you very much for the presentation. My question is, so I'm actually trying to learn AI QA for hacking and stuff like that, red teaming. So I was wondering if you have any cases or have known of anybody containerizing their LLM structures and fine-tuning it specifically in like a container in order for it to not break the whole system.
Yeah.
And so I was thinking, or my question is, do you have any cases or know of any buddy doing that with Dockers at the?
You mean with packaging the weights into OCI, like, and fine tuning models and?
Correct, and breaking them at the end of the day.
Yeah, totally. Like what, some of our biggest early users were people who were fine tuning models, and we're trying to build pipelines where they were fine tuning the model over here, putting it into a thing, and then pulling it into some sort of eval cluster to like see whether it was right, and building big loops like that, and using Docker's ability to kind of like move data around efficiently to just sort of simplify the automation of that. So that's kind of huge. And one of the active areas of research, I'm not kind of involved in this, but Docker is heavily involved, is kind of like Docker's always been based on the idea of layers. Mm-hmm. So, like your base layer has Python, and then this layer has some like, Python code or whatever. And with weights, when you're fine tuning, doing the same thing, where you can cache big chunks of the weights, but then just like move around layers of updated weights. There's lots and lots of like cool research going into that.
Perfect. Thank you.
Right. Thank you.
Jim, it was a great presentation. Thank you very much. My question was about the last demo that you showed about the Garmin app. So if an app is exposed on an API endpoint, would you say that it can be an MCP server, or an MCP server can be built out of it? And
totally, yeah.
Okay.
Yeah.
And so can you, for example, talk to your model about what is the average calories burnt on the same circuit that you've run, and could you like maybe draw second, third insights using the data?
Yeah. It's really fun. Like it's doing analytics with this stuff is great. Like getting an MCP that has like a Postgres database. Like I mean, 6 months ago, I always thought if I'm going to build a database, I'm going to keep it forever. Now I keep my databases for like 8-9 seconds at a time. Like, I can't believe I use them like pencils. Yeah. And so the idea that you bind to an API, pull stuff down, put it into a database, keep it out of your context window, like all these weird things. Like we're learning to do things very differently.
Makes sense. Thank you.
Thank you. Anybody else? Okay. Oh, sorry. Let's see.
Great talk, Jim. I had one concern. Like you brought up security, and it seems like our data is going to be floating around a lot in the future.
Yeah.
Between MCPs and models and Docker containers. Can you talk a little bit more about, like, just at a high level, like in terms of security, what are you guys thinking is going to become the future scenario of data movement and security here?
Yeah. So I think like, I'll just like go back to this picture. Like, we just acquired a company called MCP Defender that works in this space, and the idea there is that this is there's a lot that can be done here with like tool poisoning and some of these like novel attacks to be able to index the sort of data that goes back and forth there. I think because each container is isolated, one of the things that you can add here is like, let's just say that we go back to the question about like, hey, I got this Garmin thing, and it should only talk to one endpoint. You can shut down the networking on this to just one endpoint, because again, it's Docker, right? You can also just say you don't get any network. And so you can, each one of these things is technically a Linux container, like is a sandbox. So as we start to get more creative, you've got ways of sort of thinking about security a little bit differently. There's also volumes. So we can start to have side channels between MCPs that aren't going out to the LLM, that are orchestrated by MCPs, where they just exchange data over volume. So these sort of like trusted perimeter work. This is possible now. And it's possible in the cloud. It's still like, without losing your ability to move things around. So I think it's a great question. There's just so much opportunity to optimize.
All right, thank you.
Sure.
We're gonna take another last question.
Hi. So I mean, for this model weight has to be pulled to the containers. The model weights has to be pulled to the containers, or can you?
The model weights are a container. Oh, no, sorry.
For a model.
The model weights are in what often we call a Docker image. Okay. So the model weights themselves, the data, is in an OCI artifact, and then like the LLM runner is also a container.
Sure.
Yeah.
So, but what if the model, since some of the model weights are so large, so does that mean that, because if I want to use like a Google LLM, I mean, I don't have to pay for the GPU clusters and all, but if the model is a large model,
oh yeah,
do I have to pay for the?
Yeah, good question. So these are all, the only thing we have is open source models. But some of them can be very large. Like if you've got a great machine and you've got like a 40 gigabyte model, it's fine. Yeah. Yeah, but there's nothing that any of the formats have in them that we can't put into OCI artifacts or Docker artifacts or whatever you. Yeah, I mean, in terms of like in that area, probably less so. But in like heavily like a good relationship with we have a lot of partnerships on the MCP side. We're starting to build more partnerships on the model side.
Okay, thank you, Jim.
Yeah, thank you. That was fun.
I'd like to open up a floor for a community demo. If you're building something interesting and I want to showcase here, then I can give you 5 minutes per person. Is there anyone who wants to showcase your project? No one? Okay, then I'll close the session. But Aziza, do you want to talk about?
Hello, thank you so much for being here tonight. It's great to see so many faces out in the crowd, new faces that I haven't seen before. So we're excited to have you all here. We hope to see you at future events. And when you have the opportunity, come over and scan one of these QR codes. We have some gifts that we're giving away, and we have some free trials for Vertex AI so that you can learn or start building with some GCP tools. Thank you to Docker as well. Thank you to Annie, and I appreciate our host for having us here at GitHub. And I hope you enjoyed today's talk. And if you have questions, please reach out to the two speakers with more